So let's begin the second half of Chapter 7, which has a ton of formulas. So for people that are good about memorizing them early on, it will go better for you. What we're going to do here are the sum and difference identities. So let me just ask you guys real fast. If we have the square root of 2 plus 4, can you go ahead and distribute the radical and say radical 2 plus radical 4? No, you can't do that. And that's similar when you're taking a look at something like sine of a plus b. Okay? You cannot distribute the sine. This is sine of a quantity. And to calculate this, you have to use the sum and difference identity. So here it is. What you do first is you take the sine of angle A, and then you multiply it by the cosine of angle B. Ugh, but there's more. Plus, now you're going to take the cosine of angle A, his turn for a cosine, and times the sine of angle B. So it goes sine A cosine B plus cosine A sine of B. They each take turns. All right, what does it look like if we have the cosine of A plus B? Okay, once again, you don't distribute. Maybe we could add that up here. If we have the cosine of A plus B, you do not say cosine of A plus cosine of B. That is not the right formula. It's going to be this nice fancy formula right here. Okay, so his formula has to be a little different. It's cosine of A times cosine of B. He gets two cosines right in a row. And then minus, yeah, I said minus, then it's sine of A times sine of B. And so these are very long formulas, but fortunately I have a way for you to remember them. Okay, and there's a song I'm going to ask you to sing for me tomorrow. And it goes like this. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Oh, am I clapping for fun? Not really. Not really. I'm clapping for a reason. And the reason is the switcheroo. If this was a plus, you have to switch to minus. I didn't clap up here because a plus in the problem has a plus in the formula. I'm going to sing for you again. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Okay, I want to hear you guys sing with me next time. Here's a tangent formula. Tangent of A plus B. Okay, now he is the fanciest of all the formulas. He has a big, huge fraction bar. And in the numerator, it goes tangent of A plus tangent of B. And in the bottom, it's 1 minus tangent of A times tangent of B. I know tangent is like sine over cosine. So can you tell me why there's a minus down here? Well, kind of like the cosine has a minus, he's going to get the switcheroo in the bottom. I have yet to hear anyone sing a really cool song for tangent, so if you have one, I would love to hear it. Usually it just goes something like tangent, 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 tangent. And it's hard to get a good rhyme when you only have one word for your song. But these songs are really cool. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Now, there are 3 more rules, because we haven't even done the difference identities. But luckily for you, I'm going to simplify them. In fact, we're just going to put them right here. If the problem was sine of A minus sine of B, so just add a little red minus there. If the problem has minus, then the formula gets minus. If cosine starts with minus, he's going to get a switcheroo, and you put a plus. So it's either the blue or the red pen. If tangent starts with minus, then you put a minus in the numerator of your work and a plus in the denominator of your work. So there's the next 3 formulas. It's the same as the first 3. Sine, cosine, cosine, sine, 3.14159. That was pi. Okay, we're going to evaluate using sum and difference rules. So the reason why we know they have to use these formulas is we don't have, or we don't know, 15 degrees from the unit circle. So we have to figure out equals. how can I do a 15-degree angle by either adding or subtracting? I know I could do 5 plus 10, but we don't know 5 or 10. So we have to pick angles we know from the unit circle. Well, I know what we could do. We could do 45 minus, 30. So try to think of two angles that you know from the unit circle. And now it's time to sing a cosine song. Let's see, where's those songs again? Sine, cosine, cosine, sine. All right, cosine, cosine, sine, sine. So let's write cosine, cosine, little clapperoo, plus sine, sine. And now we're going to fill in our angles. First you put the 45, then you put the 30. Then you put the 45, then you put the 30. And what happens is they each take a turn. Okay, and now all you have to do is tell me those angles that you know from the unit circle. If you know all of these fractions, you'll be good to go. Cosine of 45 is radical 2 over 2. Cosine of 30 degrees is radical 3 over 2. Sine of 45, radical 2 over 2. Sine of 30 is 1/2. Okay, so we have to know the formula. We have to know our unit circle. Now you have to know how to do fractions. When you're multiplying fractions, don't say cross multiply. You just multiply numerator with numerator and denominator with denominator. So this first fraction, radical times radical makes radical 6 over, now that's not a common denominator, that's 2 times 2, that's going to be a 4. Over here, radical 2 times 1 is radical 2 over 4. And so let's go ahead and add these together. Common denominator is 4. And what happens if the radicals are not like? Then you simply keep them apart. Radical 6 plus radical 2. You cannot cancel radical numbers with regular numbers. And you cannot add radicals that are different. And so that is the exact value of cosine 15 degrees. That's exact. If you typed it in your calc, you'd get a bunch of decimals. That would be equal to that. All right, let's try it again. Let's try to figure out what fraction is sine of 1 pi over 12. So we have to do sine. So the first thing you do is you try to figure out some fractions. And we're going to make common denominators of 12. 12 plus 12 would make a common denominator of 12. Now I have to make a 1. So I'm probably not going to be able to add. I'm probably going to have to subtract. And let's see. I could do 2 pi minus 1 pi, but I don't know 1 pi out of 12. So I have to figure out how to make a 1 with fractions that I know. Should I do 4 minus 3? Or should I do 3 minus 2? I probably don't want to do 5 minus 4. I don't know 5 out of 12. If I did 3 pi out of 12 minus 2 pi, would that make 1 pi out of 12? Yeah, it would. But are these angles that we know? Hang on, let's see. 3 pi out of 12 reduces to 1 out of 4. Is that an angle we know? Absolutely. And 2 out of 12 is 1 pi out of 6. Okay, there are many ways, many different angles you could put here. Some people try to stay small, so they end up in quadrant 1. Some people try not to do negatives. There's different techniques, but as long as it's two angles that make 1 out of 12 that reduce to something you know. Okay, and now it's time for that song. The sine song goes sine, cosine, cosine, sine. And then you put the angles in. Pi out of 4, pi over 6. Pi over 4, pi over 6. That's how it always goes. A, B, A, B. And if sine has a minus, the formula gets a minus. Okay, unit circle time. Time to tell me some answers. Sine of pi over 4 is radical 2 over 2. Cosine for pi over 6 is radical 3 over 2. Cosine pi over 4, also radical 2 over 2. Sine pi over 6 is 1/2. Okay, it's multiply time. Radical 6 over 4 minus radical 2 over 4. Common denominator is 4. Some people tell me when they're doing these problems, a lot of their answers start to look alike. I always get radical 6's and radical 2's. Well, the unit circle has a lot of the same fractions, remember? Radical 3 over 2, radical 2 over 2, and 1/2. So a lot of the answers will look similar, but these are very different. Okay, let's do a couple more. Oh, maybe we should sing first. Ready? Hit it. Sine, cosine, cosine, sine. Cosine, cosine. Sine, sine. That was fun. Okay, let's do a tangent. Tangent is the only one that doesn't have a song. Maybe I'll hear one tomorrow. Okay, we need to make 5 out of 12. So let's put some big parentheses here. The common denominator is 12 and 12, and of course they're pi's. And we have to figure out how to make a 5. I could do 1 plus 4, but I don't know 1 out of 12. So how can we make a 5? Should we do 3 plus 2? 3 plus 2 makes a 5, but are these fractions that I know from the unit circle? Let's see. This would make tangent of pi over 4 plus pi over 6. Perfect! I do know both of those. Okay, now it's time to use the formula. Tangent has a huge fraction bar. Let's just remind everyone of the formula for tangent. There it is. If he has a plus in his problem, he's going to get a plus in the numerator. So we have to know tangent pi over 4 plus tangent of pi over 6. We're going to put the angles in. Okay, you don't ever say tangent of radical 2 over 2. That's the next step when I ask you what is the tangent. In fact, it's not even radical 2 over 2. It's going to be a 1, right? 1 minus tangent of the first angle, tangent of the second angle. So we write tangent of pi over 4 times tangent of pi over 6. The good thing about this formula is the answers that you put in the top there and there are the same answers there. So what do we have to know? We have to know this tangent and this tangent. 1 minus tangent, tangent. Tangent for pi over 4 is, well, that's just a 1. I'll put 1 there and 1 down there. Now pi over 6. Pi over 6 tangent is sine over cosine. So what is the tangent? Let's go ahead and rationalize and say radical 3 over 3. Radical 3 over 3. Okay. Now what we're going to go ahead and do is simplify this up a little bit. 1 plus radical 3 over 3. 1 minus radical 3 over 3. A couple of things are going to happen here. I'm going to write 1 as 3 over 3. 3 over 3. And this 1 is 3 over 3. Wow, we got a lot of common denominators now. Got a lot of common denominators. So what we're going to do is we're going to write 3 plus radical 3 over common denominator 3. And then down here it's 3 minus radical 3 with common denominator 3. Can we cancel a denominator of 3 with a denominator of 3? Absolutely. So now we've simplified this to 3 plus radical 3 over 3 minus radical 3. All right, that is looking real good. But that is not finished. Okay, so we're going to have to go ahead and rationalize this. So we're going to multiply top and bottom here. Okay, maybe we should put a little star. And I'll put a note up here. Rationalize with, you betcha, conjugates. Okay, so we're going to have to multiply top and bottom by the conjugate of the denominator. I want that radical to go away, so I need to multiply by 3 plus radical 3. And what I do to the bottom, I'm going to do to the top. Okay, this problem is taking up a lot of space. Firsts, 3 times 3 is 9. Outers, that's 3 radical 3. Inners is another plus 3 radical 3. And lasts is plus 3. Over. Firsts, this is difference of squares. So we're going to have 9 minus, and then the lasts is just a 3. Okay, let's simplify this. 9 plus 3 is 12. Plus 3 radical 3 plus 3 radical 3s. Those are like radicals. That's going to make 6 radical 3. And the denominator is 6. I'm going to give them each their own 6. And so what we have here is a final answer of 2 plus radical 3. Okay, they do clean up rather nice sometimes. It just takes a lot of work. Okay, let's try tangent again. Holy cow. You big writers better scale it down a little bit, huh? Okay, so let's go way up high. Tangent of some pi over 12 and some more pi over 12 to make 13. Let's not do 1 plus 12 because I don't know 1 pi over 12. So let's think differently. We can do 2 plus 10. I don't know if we know those. We could do 3 plus 10. I'm sorry, 2 would have to be 3 plus 10. 2 plus 11. Oh, we don't know 11. How about 4 plus 9? Does 4 plus 9 make a 13? And let's see. That would be tangent of 1 over 3. Yep, we know that one. Let's check this one. That would be 3 over 4. Perfect. Those are two angles that we definitely know. So let's go ahead and use that tangent rule. The tangent rule says if you have a plus, we're going to have to do tangent plus tangent, 1 minus tangent, tangent. And the angles are pi over 3, 3 pi over 4. Pi over 3, 3 pi over 4. So we have to put a tangent answer plus a tangent answer, 1 minus tangent times tangent. Tangent for pi over 3, that's way up high, and the tangent is radical 3. So I'll put that answer there and here. How about 3 pi over 4? What's tangent in quadrant 2? Ooh, that's a negative 1. Negative 1. Okay, so this problem simplifies to radical 3 minus 1 over 1 plus radical 3. Okay, so far so good. And I will be looking for this answer on your test just to see if you got halfway there. But now it's time to go ahead and rationalize. So we're going to use the conjugate of the denominator. Let's multiply by 1 minus radical 3, top and bottom. Okay, so in the numerator, firsts, radical 3, outers, minus a plane 3, inners, minus a plane 1, lasts, plus radical 3. The difference of squares, that's going to be nice. Here, the conjugates are going to make 1 minus 3. Okay, let's clean this up. A radical 3 plus a radical 3 makes 2 radical 3. And negative 3 minus 1 makes minus 4. And the denominator is negative 2. I'm going to give them each their own negative 2. This definitely helps with dividing by the negative the right way. So we have negative radical 3 plus 2. It's okay to leave it like that, or it would even be okay to say 2 minus radical 3. Either one is acceptable. That's just how you arrange it. Okay, let's keep practicing our sum and difference. I see a cosine problem here, okay, and I see a difference. So we're going to have to go ahead and sing that cosine song. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. And let's go ahead and put in our angles. Pi over 2 and a theta. Pi over 2 and a theta. Now, what kind of sign should I put here, plus or minus? I did do the little clapperoo, so we're going to switch to plus. Oh, I think we can evaluate the number ones, not the thetas. What's cosine of pi over 2? It's going to be 0. 0 times cosine of theta plus what's sine of pi over 2? That's 1 times sine of theta. So this just cancels out, and we get sine of theta. That is an identity. These identities we're not going to have you memorize because you could always just do a sum and difference and make it quickly if you need it, but they're not that popular. They don't come up a lot, so we don't have to memorize those. All right, how in the world are we going to evaluate this? I don't know 80 or 20. Oh, my goodness. Look at this problem. Sine, cosine, cosine, sine. Wait a minute. Isn't it a song? Sine, cosine, cosine, sine? Is that the song for sine or cosine? I'll give you a hint. The songs start just like their names. The sine song starts with sine, and the cosine song starts with cosine. So this is definitely the sine song. This is the sine song. So I know it's sine of two angles, 80 and 20. Should I put a plus or a minus here? Does sine have the switcheroo? No, he gets a minus. Wait a minute, I can simplify this even more to say sine of 60 degrees. Perfect. Oh, but I don't want to stop there because I know that the sine of 60 is radical 3 over 2. Perfect. If it's an angle you know, go ahead and evaluate it. Go ahead and finish it off. Okay. Oh, a graphing problem. A graphing problem. This is so complicated. How am I going to graph this? Cosine, cosine, sine, sine. Does that sound like a song? Cosine, cosine, sine, sine. Absolutely. Whose song is that? Sine or cosine? Well, that's the cosine song. Okay, and the angles are x, pi, x, pi. Okay, so the angle's x and pi, and does he get a plus or minus? Cosine, cosine, sine, sine. I'm going to have to do switcheroo to plus. Okay, this is super easy. I can graph this no problem. I'm going to ask you some questions. You're going to tell me some things. What's the period? It's 2 pi over b, and the b number is 1. Okay, 2 pi. What's a section? Let's divide by 4 and get pi over 2. And what does this plus pi want me to do? Shift to the left. Okay, this is a great review. So we're going to go ahead and draw the x-axis with 1 over 2, 2 over 2, 3 over 2, 4 over 2. Who still has it? I hope so. Negative 3 over 2, negative 2 pi. Okay, what's the amplitude? The amplitude is the A number is 1. Okay, positive 1, negative 1. Let's go pi to the left. Pi to the left. And how does a cosine curve start? High, middle, or low? High is correct. So let's go ahead and go down, down, up, up, down, down. All right. Great job, guys. And don't forget, sine, cosine, cosine, sine, cosine, cosine, sine, sine. See you tomorrow.